continuidade às palestras, convidamos o Dr. Mohamed, do Departamento de Ciências Agrícolas da Faculdade de Ciências do Allama Iqbal, Islamabad, cujo título da palestra é Acelerando do sequestro de carbono do solo por meio do manejo integrado de nutrientes e cultivos reduzidos para um sistema sustentável, de arroz e trigo no Paquistão. Seja bem-vindo, doutor.
Very brief about my introduction. I'm Dr. Shaukat, working as a lecturer at Department of Agriculture Sciences, allama Iqbal Open University, Islamabad, Pakistan. Today I will just discuss about the some findings from my doctoral research, and I will cover the topic that is accelerating soil carbon sequestration through integrated nutrient management and reduced tillage for sustainable rice wheat system in Pakistan. Can you? Okay. These are just these. I want to show some famous places in Islamabad. The most famous and the largest mosque in Pakistan, that is Faisal Mosque, also situated in Islamabad. The next one, the place for attracting to the visitor. Then Centaurus Mall, Dr. Daniel also visited to exchange some money. This is the overall the agricultural system. Pakistan, fortunately, we have 4 seasons in Pakistan, and we can grow more than 2 crop in a single year. Next, please. Just for the student, for the researcher, about the definition of carbon sequestration. It is the process in which we capture the carbon dioxide from the atmosphere and we store in different sinks in terrestrial ecosystem. We have to measure sinks for capture of the atmospheric carbon. The warming of our earth is increasing day by day due to a high concentration of carbon dioxide in the atmosphere, and we can reduce this increase in temperature by reducing the emission of this gas, as well as the removal or capture of already presented carbon dioxide in the atmosphere. Next, please. In my doctoral research, I conducted the experiment on rice wheat production system in Pakistan. As we know, the rice wheat is the largest production system in South Asia. It covers around 13.5 million hectares, and among the countries, India is the largest producer, while Pakistan also has a significant contribution in this production system, and we have 2.2 million hectares. Very brief about the total area of the Pakistan, that is 79.6 million hectare, and out of this we have only 20 million hectare cropped area, and in this cropped area 77% is irrigated and rest is rain-fed. In Pakistan, we are producing world famous rice which has very nice fragrance, and the major point for rice growing in Pakistan are Gujranwala, Sheikhupura, Sialkot, Hafzabad, and Nankana Sahib. These are the major point in Pakistan where we are producing the world famous and fragrant rice that is being exported in USA and other countries. Next, please. Very brief about the methodology. The statistical design in this research was split plot, and each treatment was replicated 3 times. The location where I conducted this experiment was agronomic research area of University of Agriculture, Faisalabad. In rice and wheat, I maintained 12 rows in each pot with row to row distance between the lines was 22.5. In the case of rice, we maintained plant to plant distance 22.5 centimeter. Next, please. This is the treatment plan. In main plot, we maintain the conventional and reduced tillage. In conventional tillage are those practices which the farmer are practices in their area. These are 2 cultivation plus 1 rotavator for wheat and 3 cultivation for rice. While we reduced the frequency of tillage, 1 rotavator and 1 cultivation for both crops. The next, that is nutrient management practice, where we don't apply any fertilizer, that is control. Then recommended chemical fertilizer for rice and wheat was used. Then farmyard manure at the rate of 20 ton per hectare. Actually, this rate is the that rate which for our progressive farmer are using in their lands. Then the next treatment was incorporation of the whole stubbles, just to remove the productive or green part from the crop, and the whole stubble was incorporated. The next, there was the combination of recommended and 50% of manure, then recommended synthetic fertilizer with 50% of stable incorporation. Then the combination of 3 ingredient, which is recommended NPK along with 25% manure, then with 50% crop residue incorporation. The last treatment was recommended NPK with 50% manure along with 25% residue incorporation. Next, please. These were the initial the basic properties of the cell sample collected. Organic matter that varies about 0.5 percent. The clay silt sand fraction was 27 54 19 at 0 to 15 cell depth, while the total nitrogen and available nitrogen was 0.41 and 7.07 gram per kg of cell at 0 to 15 centimeter cell depth. Overall, these are the physicochemical characteristics of the cell that was used in this experiment. Next, please. These are the basic characteristics of the amendments which were used in this experiment. The animal manure, which has around 39.5% moisture, 29.6% carbon, and 0.8% nitrogen, 0.21% phosphorus, and 0.61% potash, with CN ratio of 37. Same case was rice and wheat straw. Next, please. Okay, then determination of harvestable carbon biomass and carbon input. How much carbon biomass we harvested in the case of rice and as well as in the case of wheat, and how much the input per treatment, carbon input per treatment was incorporated in our experiment. We can easily calculate the total average total harvestable carbon biomass of rice and wheat by just using this equation, that is given how much the grain yield or straw yield we have, that is multiplied by the constituent, their constituent. We can get the total carbon biomass harvested in the case of rice and in the case of wheat. Next, please. Then, how much the organic carbon input was incorporated in each treatment was determined from the below ground carbon biomass, stubble plus leaf fall, and then which were incorporated in the topsoil. Then the external carbon input in the form of manure and crop residues. The, okay, next, these were the equation which was used to calculate carbon input from different fraction, from below ground, from root, from residue deposits, from you can say leaf and stem fall of during the harvesting. Some leaf and stem falls on the grounds, and these were calculated, and the input and average carbon input from this fraction was calculated. Same, the external input we used was the stubbles as well as manure, and how much the carbon was in stubble and how much in manure was also calculated in each treatment. Then we calculated the soil carbon sequestration, as we have the soil organic carbon before the experiment as well as after 2 years, as this experiment was comprised two year time period. At the end of the experiment, again the soil samples under each treatment was collected and was subjected to the laboratory analysis to analyze the final carbon contents in each treatment, and this equation was used to calculate soil carbon sequestration. Next, please. Next. These are the results of carbon inputs from different treatment. The maximum carbon input were recorded from manure treatment under both tillage treatment, and that was followed by the you can see the combination of NPK, manure, and stubble. Next, please. This table shows the organic matter in at the 0 to 15 and 15 to 30 centimeter depth, and the under conventional tillage the maximum organic matter was 12.61 gram per kg of the soils over 0 to 30 centimeter soil depth under conventional tillage, while under reduced tillage, this treatment resulted in 12.81 milligram per kg of the soil, and the fraction of NPK, stubble, and 50% manure also give the similar, you can say, statistically similar reading, that was 12.8 gram per kg of the soil. Next, please. This graph shows the harvestable carbon biomass of rice and wheat under each treatment, and the you can say the yellow um, shaded bar shows the harvest carbon biomass of wheat, while the blue one that is indicating the harvest carbon. Sorry, the blue one indicating the harvest carbon biomass in the form of wheat, while the you can get yellow shaded indicate the harvest carbon biomass in the form of rice. And you can see under conventional and reduced tillage the 50% NPK and 50% manure resulted the maximum rice and wheat harvestable carbon biomass. Next, please. These graph shows the average soil organic carbon sequestration rate at 0 to 15 centimeters cell depth and 15 to 30 centimeters cell depth. The right hand graph shows the maximum soil carbon sequestration was observed from the combination of all uh, in external amendment 25% NPK and stubble along with 50% manure resulted the higher soil organic carbon sequestration under reduced tillage. While at the similar result were reported at the cell depth 15 to 30 centimeter. Uh, Next, please. This graph shows the nitrogen sequestration at 0 to 15 centimeter cell depth. We observed negative nitrogen sequestration and carbon sequestration at 0 to 15 centimeter. In previous graph, there was these reading was also in negative. The nitrogen sequestration under control uh, is also negative, while the maximum nitrogen was sequestered under 20% NPK and stubble along with 50% manure, and that was followed by the same treatment under conventional tillage. Next, please. This graph shows the nutrient effect of nutrient management on soil nitrogen sequestration under both tillage treatments at 15 to 30 centimeter soil depth. And we can observe that the maximum nitrogen sequestration was reported with by the treatment that is 25% NPK stubble along with 50% manure, and that was followed by the stubble treatment under reduced tillage. Next, please. This graph shows the relationship between soil organic carbon sequestration and annual carbon input under conventional and reduced tillage, and the regression equation shows that in the case of reduced tillage, the humification percentage was 13.5, while under conventional tillage, the humification percentage was 14.8%, and the relationship was significant, and the 67% the variation in the case of conventional tillage was dependent on the input, while in the case of under reduced tillage, the 62% the you can say the soil organic carbon sequestration was controlled by the carbon inputs at 0 to 15 centimeter depth. At 15 to 30 centimeter depth, the humification rate was decreased and it was around 10.7%, and the value of R square was varies 0.60 to 0.61. Next, please. Okay, and this graph shows the relationship between cell carbon input and change in cell organic carbon content at both cell layers. The lower dashed line is indicating requirement of annual carbon input to maintain initial soil organic carbon level in the cells, and you can see under conventional tillage we must we must incorporate around more than 2 ton per hectare per year to maintain initial carbon in the soil, while under reduced tillage it is less than 2 ton uh, per hectare per year. Next, please. This graph shows the relationship between carbon and nitrogen stocks with soil bulk density as the increase in carbon and nitrogen stock resulted in decrease in bulk density. Next, please. This graph shows the relationship between nitrogen and carbon stocks with soil bulk density at 15 to 30 centimeter, and the trend was similar trend was reported. Next, please. This graph shows the regression relationship between nitrogen sequestration rate and nitrogen input, and we can see as we increased input of nitrogen up to 150 kg per hectare, the sequestration of nitrogen was linearly increased, while a further increase in nitrogen resulted in decline in nitrogen sequestration at both soil layers. Next, please. Okay, thank you. Any question, please?
Agradecemos ao Dr. Mohamed pela sua participação e por dividir seu conhecimento conosco. O Simbras 23 agradece.
O 11º Simpósio Brasileiro de Agropecuária Sustentável e 8º Congresso Internacional de Agropecuária Sustentável. Evento online, dia 5 a 7 de outubro, cujo tema central é os novos Objetivos de Desenvolvimento Sustentável em nível global. O intuito que ensejou a escolha do referido tema é o de apresentar discussões e proposições relevantes em que a comunidade acadêmica e geral demonstre consciência acerca de suas responsabilidades sociais, econômicas e ambientais para um real desenvolvimento sustentável. Esta edição está repleta de conteúdos valiosos e oportunidades de aprendizado. Temos o prazer de oferecer uma série de palestras ministradas por especialistas renomados, tanto no cenário nacional quanto internacional. Além disso, temos uma variedade de minicursos disponíveis com temas que foram cuidadosamente selecionados para proporcionar a você uma visão abrangente e profunda sobre diversos tópicos relevantes. Você também terá acesso ao livro online de Anais de Palestras e aproximadamente 300 resumos expandidos que foram aprovados e que também estarão disponíveis online em forma de livro. A adoção de materiais e recursos alinhados com a responsabilidade socioambiental, com o objetivo de se adequar às práticas sustentáveis, é fundamental. Pensando nisso, toda a divulgação do evento foi realizada por meio de canais digitais. O Simbras é um evento multidisciplinar e interdisciplinar que envolve pesquisadores e professores de diversas regiões do Brasil e de outros países. Nossa comissão organizadora e parceiros trabalha desde 2009 preocupados com esta linha de desenvolvimento sustentável bem antes da palavra sustentabilidade ser usada com tanto destaque. Ao longo de suas edições, vem contribuindo para as discussões inerentes ao estado da arte das temáticas relativas às práticas sustentáveis no âmbito das pesquisas, ao conciliar a perspectiva de renomados pesquisadores internacionais e nacionais, bem como pesquisas de estudantes de graduação e pós-graduação. O evento contribui para o desenvolvimento de um senso crítico no âmbito da produção científica dentro do tema. O Simbras é uma oportunidade da divulgação de conhecimentos e soluções aos problemas globais, em busca de sistemas produtivos mais sustentáveis. Agradecemos a todos os participantes.